What's up guys, Shawnthebro here, and today we're going to be going over positioning weapons in our hands properly. There are going to be some issues because of the animation itself. It might not look completely correct, but if you remember in the previous episodes, the guns wouldn't even show up in the character's hands because it was all going off of the same socket and we were just changing a skeletal mesh. Now we're going to actually be attaching the correct weapon when we pick it up. And remember we were using our pointers earlier and I said it was a little bit weird? We're fixing that too, just by simply attaching the actual object that we pick up. So we're going to handle both of that in this episode, and we're also going to handle looking up and down. Once we attached our camera and our weapon to our mesh, it took away our ability to look up and down. We could only look left and right. We technically could look up and down, but it wouldn't do much. It would just basically look back and forth. So because of that, we have to make some adjustments to the way that the animation blueprint controls the rotation, because we can determine all this in the Anim Graph. So first things first, let's go into our Anim BP for our character. And since I don't have a weapon animation yet for shooting, I went ahead and took off the shoot animation because for me, I have a generic shooting animation, but it kind of doesn't look good the way it moves the bones. I need to make one or find one that fits. And really, we don't need the character so much to have a shooting animation, but more so the weapon to have a shooting animation. So for now, I've just disconnected the logic. I've taken out the Boolean that determines if we can shoot or not. And so we won't enter that animation. That way when we're sitting here shooting, the gun doesn't move, but we also don't move, so we have a good angle here so that we can see what's going on. Alright. And before we get started on this new logic today, if you want to get caught up in all the episodes, I'll go ahead and leave the playlist right here. You can see how we got to this point. This episode is very important. I'm very excited about it because this basically wraps up all the things that we had done incorrectly in the past. Or not necessarily incorrectly, but we were doing it kind of as a placeholder because we wanted to, get to certain things quicker. But now we're going through the system and really doing it the right way, and this basically eliminates the rest of the stuff that we had done early on that needed to be adjusted. So that's all you need to do in the actual state machine, but we can go to the Anim Graph if you just double click on this Anim Graph section right here. The Anim Graph basically determines what pose is going to be output to the character's mesh, or to the owner. In this case, we have our character BP linked to this animation blueprint, and that's where it renders to. But this output pose is what actually gets sent to that. So if certain things aren't adjusted, then they won't be shown off. The way we attached our character, the camera and our weapon to our character's mesh, didn't allow for us to move up and down. It was only going off of left and right rotation. In the FPS template that you get from Unreal, you can move up and down, but that's because you're just arms that can rotate. Our mesh didn't support any sort of rotation. So to do this, we have to actually make the spine be able to rotate. Okay? So you should see your state machine here. This is what I was just in. This is where I was before. And you should see your output pose. And these should be connected. All you have to do is move the default state machine back, and we'll fill in these things. This is pretty much the standard way to do it for any sort of game where you need to modify the bones to look vertically. Essentially what you do is you convert the local to component, and then component to local. The things in between are to transform the bones themselves with the vertical rotation. The only bones we care about for the Mixamo model are the spine. In some cases you might care about them more or less. You might care about different bones more or less. But in our case, we really only care about the spine, and this goes for all Mixamo models. So you'll see this is the standard for Mixamo models. Basically, just do local to component. Whoops. There we go. Basically, it'll convert the pose that you have to a component space pose, which means we can modify individual elements of the the skeleton here. We need the component pose for the transform. That's the important part. We can't just drag this in. Technically you can, but it will convert it anyway. So you can't just have the default state machine to the transform bone here. Alright, so let's get our transform node here. So this is a transform, and you have to make sure you pick the right one here. You really want transform modify bone. It looks like this initially when you use it. This is the correct node, but there's some things that we can enable or disable. Now, quick note, I'm on update. I'm on version 4.26.2, so some of my things may look different than if you're using an older version. I was previously using 4.24, and so these would normally be like a checkbox to expose as opposed to this drop down, but everything's still here. Nothing has changed in that sense. We just have to make sure we're clicking on the right options. So first things first, you'll have a bone to modify. We're going to want to modify the spine, spine 1, and spine 2. If your character has more spine, then you may need to adjust and add more of these. If you're not using mixed mode model, you only have one spine, you may only need one. It depends. The spines just break it up. If you look at the character itself, we can do this really quickly. We can look at our spine and see that there are different spots. Okay? So his spine just travels up his back like it would in real life. And because of that, we want to make sure that all of these are getting some sort of vertical rotation. You don't technically need them, but it will adjust how your character looks and feels in the game, so it's better to just do them all. Now, so pick one, for example, spine on the first one. And then for translation, we don't need it. We don't need scale or translation, or even alpha. We just need the rotation. We need to adjust the vertical rotation, and we need to adjust the component pose. So you can uncheck expose this pin. Again, if it's a checkbox, just literally uncheck it. It will disappear from the box. Look at your headers here. So go to scale. We want to keep rotation. Go to scale, uncheck that. Go to alpha and uncheck that. So we don't want to expose any of those as pins. Then you can drag your state machine directly into it and get the local 2 component, or you can just find local 2 component very easily by clicking that and plugging it in. Now, on this transform modify bone, there's one other thing you want to do. You want to make sure that the translation mode is ignore for everything. It is by default, except for rotation. We want to add to existing. Okay, we kept the rotation exposed as pin, as opposed to removing it, but we want to make sure the rotation mode is add to existing. Everything else can be left alone. Okay, and then you can copy this. Whoops, you can copy this 2 times, or for however many times you need. Connect the links, and you can drag it directly back into the output pose. It'll make something called component to local, or again, just search for component to local, which brings the component space back to local space, which is what the Anim Graph needs to play. All right, so basically we converted the state that comes from the state machine to a space where we could modify the bone values, and then we converted that back to a space that makes sense for the output pose. A little bit confusing at first, but makes sense, I think, when you put it like that. The only other thing we need to do is determine the rotation. Now, the rotation we're going to determine in the event graph. However, we can still link it up now if you'd like. Basically, what I did is I made a rotator called vertical rotation. So you can make a new variable, and then look at the types and choose rotator. And then you call it whatever you want. I called mine vertical rotation, and you can plug it into all of these. I've used some reroute nodes up above so that it's a little bit neater. You just double click on the line if you want to use a reroute node. Something like that. Now, I'm going to delete all of this because I have it up above. There's no reason to have it twice, but that's what it'll look like. Then make sure your bones, when you copied them, you can see it right here. It says bone, spine 1, bone, spine 2. But since you've copied these, make sure that you change the bone to modify to be 1 for each bone. Again, we only care about the spine in this case. I'm just going to relink these up. And there you go. That's what you should have in your Anim Graph. Excellent. All right. So with that done, this is actually doing everything we need to rotate our character's view vertically. But we do need to make sure that our vertical rotation is holding the right value. So let's go into our event graph. So we have this event blueprint update animation, which is essentially a tick for the animation blueprint. If we go to the end of that, that's where I'm adding it. You could technically do this in the character and have vertical rotation, but then we'd have to send it to the Anim BP or get the character reference in the Anim Graph, which is typically very bad to do. So it's better to just have the vertical rotation here. All right, it's pretty simple what's going on here. I already have a check earlier to make sure character reference is valid, just so you're aware. So if it's not valid and you try and use this, this will give you errors. But again, I already make sure if it's not valid to set it. You can see that I'm doing that right here. We only go down this path if it is valid. So we know it's valid. We're going to do something called get control rotation. So I'm going to write this logic down below as well so I can explain as we're doing it. But get your character reference. This is the actual character BP. For me, it is the base character BP object reference. And then we get control rotation. Looks like this. It has a rotator, just like our vertical rotation variable is. Now, we can right-click on this and split the struct pin, which means it will show all the variables within that struct. So now we have value X, value Y, value Z, roll, pitch, and yaw. We only care about the pitch in this case, the Y rotation, because the Y is the value we want to rotate our character on. We want to allow him to look up and down, which is the Y, the pitch. So if we drag off of this and say float greater than float, we can check if it's greater than or less than a certain value. We want to make sure that if it's greater than 180, we're doing specific logic. So the reason for this is your character should only be able to look so high and look so low. So we have to make sure that the value, if the value is greater than 180, we perform different logic. If we don't do that, again, you'll be able to look the whole way around. You'll be able to go up and you'll start turning around. You'll be backward. You'll be like a snake that does a loop on itself. So we do have to set a halfway mark, and usually this is just 180 degrees because you can look fully down and fully up and not do anything behind you. All right, and then we just drag this into a branch, and we do the correct logic regardless. Whatever way it is that we need to, we do the right logic. So, for example, if it's greater than 180, then what we're doing, and I can show you what it looks like, actually, because I think that might make more sense. So watch what happens if you don't have this branch in here. So if you don't have that branch in there, then you see it snaps really hard when you get here. That's because once it reaches the certain value, it's trying to do logic that is incorrect for what we need to do. It doesn't really handle it well in the middle here. All right, and vice versa. Let's go to the other. Let's say we just did the other one. You can see it snaps. It doesn't really look right. Like, it's not really in the right position. Quite frankly, I'm underneath my legs. Things just don't look right. So we need to have both of these here. If we don't have both of these here, then it's not going to be correct. So essentially, if it's greater than 180, we're going to subtract 360 from it. I like to do a little reroute node here just to make it a little bit neater. Maybe another one. And we do float minus float. Make sure it's like this. We don't want this minus 360. We want 360 minus this value. All right. So if it's true, it's actually going to be going this way. And then we need a float times float. And this one doesn't matter. Multiplication doesn't matter. The order, at least on top and bottom like this in this case. All right, so these are your two conditions. So thinking about it logically, if we print out our pitch value here, what I can do is actually print out the result for you. And I think it'll make more sense as opposed to simply explaining it. So if we print this out, and we'll keep it a little bit ugly for now. My bad. So if we print this out, see, as I go below 0, so it takes the true branch, you can see it's taking this logic, and it goes all the way to basically 90 degrees, which is what we want. We don't really want to go less than that. We would be looking inside of our stomach or even behind us, and that's good. And you see how it cuts off and lets for the other branch to take place. That's why it was jumping before. All right. Now, if we do the same thing here and print out this value, I think you'll know kind of what to expect from this. But this is the opposite. This is if the value is less than 180 or equal to it. So basically, anytime we look up, see, since it's equal to it, you see 0. But let's look up. You see the values changing? There we go. So it goes up to negative 90. Now, if you went below negative 90 or above 90, you're going to be looking inside of yourself or behind you. That's why we have these two branches, and we have to cap it, making sure that the value is either greater than 180 or less than 180. Okay? So we can get rid of these print strings now. And actually, this works perfectly fine as is, but there is something additional you can do. You can multiply this by how many, the amount of weight that this spine will have. Now, we're doing all spines in this case, all of our spine bones in this case. So we have 3 of them. We just have spine 1, and spine 2. So for that, you can either divide by 3 or multiply by float by float again, and just do 0.33. Multiplication is a little bit faster than division, so usually better to do it this way. However, it doesn't hurt if you want to do divided by 3. I'll show you. These are the exact same in this case. Not the exact same, but they're very similar in this case. They'll work perfectly fine. I prefer doing multiplication when I know the value to multiply by, because this is essentially doing division. Multiplying by 0.33 is very similar to dividing by 3. There is some round off error, but it should be perfectly fine. And now, all we have to do is take these values that we have. These are our new Y values for our character. And we put them into a rotator. That way, the rotator can be used to determine the pitch of the character. So now we say make rotator. All right. And then you're going to put it into the roll, which I know seems weird because you're like, why wouldn't you put it into the pitch? And that's a good question. But the reason for that is the roll is what handles this is a rotation on the local component for the character. So say you put this on the pitch. In fact, set this up so I can show you. Then drag vertical rotation onto the return value and just drag your true to there. I'll have to do it for the false as well. But see, I'm rotating. You see the way that it's rotating the gun? On the local, on the roll for this, it doesn't look good to rotate. All right, it rotates the spine incorrectly. In fact, if you can actually look at this, and there we go. You can see how the character has bent himself in a way that does not look natural. So the space is different. So the rotations are different. If you see your character not doing what they're supposed to be doing, maybe make sure that you're rotating on the correct axis. If you do it on the Z instead, my mistake. All right. If I do it on the Z instead and I eject means you get control of the camera. You can see he's twisting his torso, which is fine, but it's not the operation we're trying to do here. We're trying to go up and down. So in this case, we need the roll. And now when we do this, you can see it just looks normal. And if I were to actually show you this guy, the last one, look down. Now he's actually looking down at the ground. And so you do it on the other one as well. And I'm going to delete this since I already have it up above. I was just doing that as a live example to show you. If I drag this in, this is the same stuff we already just did. But this has the top and the bottom branch set up. So if I drag that in and I take one final look at this, I can play the game, I can look up, I can eject, and you'll see he also looks up perfectly fine. There you go. So it's actually bending the character, rotating him to look up. Now, depending on your character mesh and things, you may need some adjustments with how far you can look up, or the way that you might need to play a proper animation because there could be clipping or bad things happening with your spine. But at a base level, this is complete. This doesn't just look up and down like the arms where it was rotating. It was just rotating the whole thing. We're actually rotating parts of our character to look the proper direction. All right. Switch back to my regular view mode there. Now I'm going to make a quick adjustment to some of the logic we had in previous episodes dealing with switching weapons. It shouldn't take more than a few minutes if you'd like to stick around and see how we can actually pick up weapons now. As opposed to just adding it to our array, we actually pick up the one that's in the game and we can start shooting it. It also changes our type and everything like expected, so it's literally like we're picking up a weapon. We already have this system working, but we made some adjustments where the character now goes off of a weapons array and pointers, and that works fine, but we need to make sure that it also works for these new weapons we're picking up. Now that we fixed the looking up and down, I think it's the right time to do this. So we'll do this quickly. But in our base character BP, we go into it. We were in begin play, spawning the base weapon BP, adding it to our weapons array, and attaching it to the correct socket. And that's how we got our weapon to look like we did. We were then calling the switch weapon mesh function. And we were switching the skeletal mesh of the gun and the projectile class. Now, we don't want to switch the mesh. We have actual objects we can use and attach. So instead, I've made an event switch weapon, which in code looks just like switch weapon mesh, except it takes in a weapon type. This is a blueprint implementable event, so we don't have to fill out any logic in the CPP. This is my base character, the character that I want to call this event on. And I just have switch weapon. It's important that these are different because switch weapon mesh was actually okay. When we originally started this series, we were doing it more Doom style, where we just pulled out whatever gun we needed, and we didn't need like a specific animation for it. The character just held it. But now that we actually have our character mesh and everything, we want to make sure that our weapon actually lines up with the animation that we'll need and at the spot we need on the mesh. So this is a more advanced way of doing it. All right. So once you've written that, the only thing we need to update is where we were calling switch weapon mesh, we need to also call switch weapon. You don't need them both. I just haven't taken it out to not confuse you guys. But you can feel free to take out switch weapon mesh if you don't want to use it anymore. So if you scroll down to the bottom, we have this function called switch to next primary weapon, which gets called when we do our equip logic. Before I was calling switch weapon mesh and doing this. Now I'm calling switch weapon with weapons, weapon index, weapon type, as opposed to the index. We want to know what type it is so we know what weapon to spawn and also perhaps what animation to change in the future to be able to hold the weapon correctly. If it's not a success, meaning we don't have another weapon afterward, we go back to the initial index and we do the same logic. We switch weapon, weapons, weapon index, weapon type. Build that, open up the editor. And then here's the logic for event switch weapon. So to switch a weapon, we're going to do something called detach current weapon, which is going to get rid of the weapon that we currently have. And then we're going to perform a switch on the type, which was the parameter that we brought in, and attach the appropriate weapon. Now, quick note, I have added sockets for each of these. You can preview it just like I've shown in my other episodes, so I won't go over that. But you can just preview an animation just so I can show you. This is what the SMG looks like. And see, it doesn't really fit with the animation. So I made it look good in the viewport for the character so that they can see the gun now when they're holding it, which we couldn't do in the past. Now we can, but we're going to need different animations depending on the gun to make sure that they look correct, because this is not how you should be holding that weapon. And I have weapon socket, which is just the base socket, AR socket, and SMG socket. So it's very simple. Let's go into event switch weapon first, into detach current weapon. This is a function I've made. So if you go into functions, new function, when you hit this plus, it'll automatically create one. I called mine detach current weapon. Now the logic I'm doing here is pretty simple. We are attaching these guns to our mesh when we use them. So when we want to stop using them, all I'm doing is detaching them from the mesh. You could actually destroy them, but I haven't decided if we want to throw them on the ground like Halo style when you pick up a weapon, or how we want to handle this yet. So right now I'm just detaching it and just leaving it where it's at. So detach current weapon. We grab the mesh of our character. We get children components. We loop through them. Right? We get the object name. This one is this is a little bit of a hacky method. I just want to make sure that it's not a camera. We have our first person camera here that now handles where our view is. We don't want to remove the camera by mistake. We could have multiple things attached. So for now, I'm just going to get object name, not map contains, sorry. Type contains, but make sure you use the string contains. And we want to put in the substring camera. We want to make sure we're not removing a camera. And then we do a branch, and only if it's false that it contains camera, we detach from component. The component doesn't really matter at this point. That's what we're assuming. However, very well could matter, and really what we should do is just check for a weapon and have a naming convention. Okay, so off of the array element, detach from component. You can keep everything relative and call it modify, and that's fine. There you go. Just like that. So this is my detached current weapon function. We call that in switch weapon. Then we use the weapon type to do a switch on eWeapon type, which is something we made earlier in the series. Enum that determines what type of weapon it is. Then lastly, we have to make sure that we're attaching the correct weapon. We have this thing called interaction actor, which is how we know if we're colliding with the actor in the scene. So if we're overlapping with a box that says yes, you can equip this, then the actor tied to that becomes our interaction actor. So we had these, these three weapons in the scene. Whatever one we go to pick up is our interaction actor. So we're using that as the target, and we're calling something called attach actor to component. So attach actor to component. We want to attach the interaction actor to the mesh, because the mesh is the one with the socket. It's like that. And then we want to put in the socket for the appropriate type. The first one's the assault rifle. So I want to put in the AR socket, because AR stands for assault rifle. Make everything snap to target in this case. And keep weld simulated bodies. The next one is the pistol, which is my basic, so I call it weapon socket. Everything snap to target. And last is submachine gun, so I call it SMG socket and make everything snap to target. Alright, so I'm going to delete this one we just made. And you can see the switch weapon mesh event is completely removed. So that's switch weapon. Now when we go into our game, we can shoot normally. We can also pick up a weapon off the ground and start shooting it. It does have its own fire rate, its own name, its own ammo. Everything is actually how it's supposed to be. Then we have the SMG. And then we can go back to the pistol. We do have to make some adjustments to make our collision work properly for our enemies again. Just because of how we set up in the past with our ammo. Again, we were just changing the ammo type, or the ammo mesh instead of the ammo type, so we need to actually adjust it to make things look good. And we need to adjust some of the animations, because like walking left and right with this animation doesn't look good. However, at this point, we have a fully functioning system where we can pick up and change our weapons and look in any and all directions. So anyway, guys, that's all I got for you today. Thank you so much for watching. If you enjoyed, please subscribe. It does more for the series than anything else you can do, and I just really appreciate it. I want to give a huge shout out to my YouTube membership and Patreon supporters. Thank you guys so much for continuing to support everything I do. I really appreciate it, and I can't wait to see where these series go. Lastly, if you had any issues, feel free to join the Discord community. It's completely free, and we'll be happy to help you with any of the problems you had. Thanks again, guys, for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.